Okay, this brings us to topic number 12, a huge topic on quadrilaterals. I mean, triangles are the number one thing probably on the test. The number two thing is the next step up, which is a quadrilateral. And here are the five main types of quadrilaterals that you should be very familiar with. Just going over the basics, a trapezoid has two sides that are parallel, or one pair of parallel sides, while a parallelogram has two pairs of parallel sides. If it's a parallelogram with congruent sides, it's called a rhombus. If it's a parallelogram with all four angles being 90 degrees, it is a rectangle. And if it has all four sides the same and all four angles right angles, then you're looking at a square. So those are the basics of the shapes. And I mean, along with the basics, there are many other features that are true about the shapes. Here are some main ones to be very familiar with. That when you're talking about a parallelogram, the opposite angles are also the same. So if this angle here, this angle here is 75 degrees. This angle here would also be worth 75. Those are the acute angles. The opposite angles are the same. Another feature that happens to be true is that the consecutive angles are supplementary. So that means if I've used up 75 for both of these angles, then this angle here would have to be 105 to make a linear pair of 180 degrees. And if that's 105 degrees, then its twin brother over here will also be 105 degrees. And that works the same way with rhombuses too. If those angles are the same, those angles will be the same, and these angles will be the same. You take a 80-degree angle here, you know automatically that has to be 100, and this would have to be 100 as well, and this would have to be 80. So those are some things to be familiar with. There are some other things too as well that are as important, and let's cover that right now. Mostly concerning the diagonals. There's a lot of talk on the test about the diagonals of a shape. If I have an isosceles trapezoid, that's this picture here, with two sides parallel and two sides not, and if I know that these two sides are the same, it makes it an isosceles trapezoid. An isosceles trapezoid is special because its diagonals, I'll do those in green, its diagonals are what? The same or different? The same. It's the same distance from opposite angles. Looking at the other shapes too, and looking at their diagonals, you can get the impression of what's true and what's not true by just looking at the picture. Is that green diagonal the same as this black one here? I mean, if you had to try to measure it at least with your finger or a piece of paper, it might help you to see it. But definitely the black is not the same as the green. The black is shorter than the green. So in a parallelogram, the diagonals are not congruent. If you look at a rhombus and look at its diagonals, is the black diagonal the same as the green diagonal? No, it's much shorter again. So in a rhombus, the diagonals are not the same length. But if you look down to the next shape with a rectangle, the two diagonals are the same length. If you look at a square, the diagonals are the same length. A good way to view these kinds of questions and to think about these questions are, if two things look the same, they probably are the same. And as you get down to these four shapes in particular, the rhombus, rectangle, and square, there are a lot of congruent parts that are in each picture. If I take a look at the rhombus is loaded with lots of things that look true, and they actually are true. These are all four right angles here in the center. Also, the diagonals break up each other in a way where they're bisectors, where that point in the middle is the midpoint of both diagonals. Other things that happen to be true. This angle here is identical to this angle here. The diagonals are angle bisectors. And then also these are the same. And if you know one angle in a rhombus, or know even 1/2 of an angle, you can get all the rest. So if this angle here, or this half of an angle here, the entire angle is 60, I would know that 3 other angles would also have to be worth 60. If they look equal, they are equal pretty much in the rhombus. The rhombus has lots of facts that are true about it. And then if I look at just one of these triangles, I've got a 60-degree angle and a 90-degree angle. All 3 angles have to add up to 180. So now I know that this angle has to be worth 30. So that these 3 angles would add up to make 180. And if this angle in the lower left-hand corner is 30, by alternate interior angles, that angle has to be worth 30 as well. And so is this angle and this angle. So there are a lot of facts here that are true, looking at the rhombus in particular. So that's, the rhombus is one that most likely will be on the exam. The rectangle, and there's a lot of things that are true about the rectangle that aren't true. There are some things about the rectangle that are true that are not true about the rhombus. Actually, all 4 of these half segments are the same, these half diagonals. One thing that is true is that this angle here is not the same as this angle here. Together they make 90 degrees. If it's not a square, these angles are not the same. If that's 20, that would have to be 70. And then you get a bunch of other angles that would have to be the same too. So on these shapes, it's good to know the properties by heart, but it's also good to be brave in this question and, you know, take some chances in terms of figuring out things by just looks alone. And if I've got 70 and 70, that's 140. So now I can figure out that this angle is 40, and then this vertical angle would be 40, and this would have to be 140 because I'm making a straight line, and it'd be another 140. So those are some things about the rectangle there that are true. The square has it all. If you ever take a guess on something and being right, then the square's got it, because the square has all the properties of a rectangle and all the properties of a rhombus. So all those are the same. All of these are the same. They're each 45 degrees. You get 4 right angles sitting in the middle there. All 4 of these triangles are congruent to each other. And that's a quick rundown of the properties. Hopefully that helped you out a little bit. All right, now on to some questions that are on the exam and some suggestions on how to run them. So this question here, which statement is true about every parallelogram? Well, sometimes you can find a picture of a parallelogram on your exam paper. If you don't have a picture of a parallelogram, make one. Draw 2 sides that are congruent and parallel to each other, and then connect the endpoints together, and you're guaranteed to have yourself a parallelogram. Are all 4 sides congruent? No, that's not necessarily always the truth. Look at my picture here. If I said that's 10, and I told you that was 8, it looks, or maybe even 6, that looks pretty reasonable. So not all the sides have to be congruent. Are all the angles inside the same? Are all the interior angles the same? No, because I've got obtuse angles, and I also have acute angles. They're not all the same. 2 pairs of opposite sides are congruent. Okay, think about pairs like a pair of shoes. two pairs of opposite sides are congruent. That is something that is true about all parallelograms. Are the diagonals perpendicular to each other? Well, if I can rule that one out by just drawing this in. This angle here in the heart of the parallelogram is not 90 degrees. So that doesn't have to be true. So that's how you should work these questions out, is take your time with it. It doesn't look like there's a lot of work to do when you just read the question, but drawing a picture, taking your time, thinking about each and every one is important. Also notice that I canceled out these two, and even though I thought I had the right answer here, I still continued to think about line number 4, answer number 4, and I decided to rule it out finally. So when you find one that you think is right, you should continue and look at the rest of the choices just to double check to make sure. There might be one that also looks right, and then you're going to have to make a decision on which one to pick. So take your time with the multiple choice. I've got, I think, 3 more questions to go through with you. Okay, here's a question off of the Regents exam, and they're being as kind as they can to you as possible here. They're giving you the picture of the parallelogram, and they've drawn in the diagonals for us. And what they're not being so nice about is they want us to find something that's not always true. And a lot of students will overlook that word. They'll read it too fast and say which one's always true, and they'll make a mistake. So we're looking for the one that's a lie. Which one is a lie? So which one is false? Or which one could be false? If you go through it choice by choice, question number 1, or choice number 1 says DAE is the same as BCE. That's true. We're looking for the one that's false. Those are the alternate interior angles based on those 2 parallel lines. So those would have to be true. They even look the same. So we cross that one out because we're looking for the one that is false. Looking at the next choice, DEC. DEC and BEA are those 2 vertical angles. Vertical angles are always congruent. Okay, moving on to choice 3. Choice 3 says that A to C, that diagonal, is the same as D to B. D to B looks definitely shorter than A to C. The only time they would be the same length would be if it was a square or a rectangle or an isosceles trapezoid. So this would have to be the one that is not true, and that's the one we're looking for. If you continue on and look at the other choice, DE is the same as EB. That is true, but we're looking for the one that's not true. So it has to be choice 3. Okay, the next question, I got 2 more left. The next question is asking for angle DBC in the rhombus below. DBC is this angle here. And if you look at the choices, you might be able to rule out something right off the bat. To me, that angle looks way too small to be worth 80 degrees. 80 degrees is practically a 90-degree angle. So there's a 90-degree angle. 80 degrees is just 10 degrees shy of being a corner. So I would rule out that one right off the bat. And you might be able to decide what the right choice is without doing any work. It's going to be choice number 1. But if you had to actually work it out, you could work it out this way. That's worth 100. The angle on the opposite side is worth 100. This red angle, angle B, the entire angle, has to add up to 80 degrees because the consecutive angles have to add up to 180. If that's 80 and it's getting split by this diagonal, and since we're dealing with a rhombus, it would tell us it would be an even split of 40 and 40. So the answer is choice 1. Alright, last question. Given 3 distinct quadrilaterals, a square, a rectangle, and a rhombus, which one must have perpendicular diagonals? You can draw a picture of all 3, and that's a good way to judge it. Seeing is believing. A square, a rectangle, and a rhombus. Which one must have perpendicular diagonals? If I connect the diagonals, if I create the diagonals there in a square, I get 4 right angles. When I connect the diagonals in a rectangle, when I intersect the diagonals, I do not get right angles as those vertical angles. In a rhombus, you would also get perpendicular diagonals. So the answer would be not the rhombus only, not the rectangle and the square. The rhombus and the square would be the one. It wouldn't be all 3. So those are some basics there. It walks you through some of the basic skills you need to know for the quadrilaterals. And there's a variety of ways they can ask you questions. But again, I guess the most important thing to take from this is, especially with the rhombus and the square, if it looks congruent, it probably is.